Hello Physics Nation, my name is Nate Larmond, and I'd like to do a Khan Academy problem from the set Choosing the Best Kinematics Equations. So I think I just did, the jumping kangaroo right here, given the initial launch velocity of 2.4 meters per second, choose the best kinematics equation. So here it is, Vf squared equals V initial squared plus 2a delta y. So if you see the word jumped, shot, thrown, falls, you can assume there is one force, gravity. That means it's a projectile. That means the acceleration is negative 9.8 meters per second per second. You can also assume maximum height means still there is no final velocity. At the apex, there is no motion. It's still accelerating, it's still changing its motion, but it's not moving. So with these two sort of secret hidden assumptions, that is, free fall acceleration and the final velocity is 0, this equation hops out at us. But, I do a screen drawing version, and then I do a, a hand-drawn version of these. And choosing the best kinematics equation really just means memorizing a few models, a few mathematical models. So this guy is the definition of average velocity, displacement divided by time. But I call this the other average velocity equation. If the velocity changes at a constant rate, it is the initial plus the final velocity, all divided by 2. And then finally, the definition of acceleration. So acceleration is the rate of change of velocity, Vf minus Vi divided by elapsed time. So here's the algebraic magic. This mess is equal to average velocity, displacement over time, but so is this. So I believe the math teachers call this the transitive property. I always say if you work for 8 hours, you earn $100, then you go to the grocery store, buy $100 worth of grocery. Well, 8 hours becomes $100, but then $100 becomes the groceries. So 8 hours of work is equivalent to the groceries. Like I said, I think the math teachers call it the transitive property. Anyway, we're going to do that. We're going to set these two guys equal to each other. Average velocity drops out, and then we solve for time. So let's see, what do? Multiply both sides by t, multiply both sides by 2, and divide both sides by the sum of the initial velocity and the final velocity. Anyway, isolate t over here, and we do the same trick. We isolate t, but now with the definition of acceleration. So we're going to divide both sides by acceleration, multiply both sides by time, and here we go. If this mess equals elapsed time and this mess equals elapsed time, we can set them equal to each other. If you set this expression equal to this expression, as I did here, you just need to clean up the algebra a little bit, multiply both sides by a, multiply both sides by the sum of the initial velocity and the final velocity, and here we go. The left-hand side becomes 2a delta x, that is 2 times the acceleration multiplied by the displacement, equals this, at first, seemingly complicated expression, but it simplifies beautifully. You just have to FOIL it out, as the math teachers say, distribute these two terms, and Vf squared plus VFVI minus VFVI minus V initial squared simply becomes Vf squared minus V initial squared. And I call this the fancy kinematics equation without time. So College Board calls this a derivation, when you take some basic principles like these 3 basic kinematics formulas and find out something new. Here's a mathematical model. Under free fall, who knew the displacement was proportional to the square of the final velocity? Who knew? Anyway, they call this a derivation. So they have these action verbs that are supposed to trigger a very specific performance on test day. Thanks for watching. See you in the next video.